So today we will look into the basics principle of hydraulic and pneumatic system. We will have a look at the operating principles of hydraulic systems. We will identify the operational characteristics, a function of the component, maintenance procedure, and of the hydraulic system. And the first thing we will look into understanding the principle of pneumatic systems. If we got time, we look at the number 3 and number 4 as well. Okay, to start with, now when we look at the hydraulic system, is used to transmit powers, high powers, as compared to the pneumatic system. We understand the hydraulic system compressibility of the fluid is not an issue, so there is no power lost because of the compressibility issues. A hydraulic system eliminates the need of complicated systems using gears, cams, and levers, so they are not there. The motions can be transmitted without the slack, so the reason is obviously non-compressibility, um, inherent in the use of solid machine parts. The fluid used are not subject to breakage as mechanical parts. You can replace the fluid. Now, if we got hydraulic systems, they are not subject to wear and tear as you got mechanical moving parts. There is more wear and tear in mechanical moving part. The reason is because there is more friction. Okay, now then there are some limitations of the hydraulic system, that's the maximum load it can lift. That's the maximum force that you can exert on that one. Now, also we need to understand, like if we are dealing with a hydraulic system, we need to understand how flexible the system is. We need to understand like what's the vibration, the dynamics the system is going through, and so on. Hydraulic system can provide variation in the motion as well. The same system can have a fast and a slow motion, different type of motion it can provide. It can transmit the power in a rotary direction, in a straight direction, at an angle, and so on. If you're using hydraulic system, it can minimize the use of the hand, um, and it's much more economical and viable to use. Now, basic principle of hydraulic system, it works on law known as Pascal's law. Now, Pascal is pressure, so the law states that pressure, if I change the color, pressure is force over area, where F is the force and A is the area. The unit of the force is Newton, and the SI unit of the area is meter square. Sometime in a system you will have force as in Newton, kilonewton, meganewton, but the area you will have that in millimeter square because the dimensions are way small. So there is a way to convert the Newton per millimeter square into an SI unit, and I'm just going to show you a quick way. Let's say the force, they say it's 57 Newton over millimeter square, and I want to convert into an SI unit. This Newton over millimeter square, because 1 millimeter, if we have a look at that one, 1 millimeter is 10 to the power minus 3 meter, but 1 millimeter square, so I need to square that side, is, and I need to square that one, so square of minus 3 is going to be minus 6. Yeah, so that's the unit conversion. So if I want to convert that one, that will become a 57 divided by Now that's Newton over meter square, 10 to the minus 6, which will give me an answer as 57 times 10 to the 6. Because this is minus 6, it goes up, becomes a positive 6. Newton over meter square. Now then we have Newton over meter square is known as Pascal. This thing here is known as Pascal, PA, because the unit for the pressure is Pascal, yeah, which is Newton over meter square. So that will become a 57 megapascal. Why mega? 10 to the 6 is known as mega. Easy way of doing that one is, if I go to the next slide, okay, let's say you are given any number, let's say 60 Newton over millimeter square. That's the easy way. You can write the straight away that 160 megapascal. Just remember, Newton over millimeter square is actually in fact a megapascal. Yeah, that's the quickest way to remember. If you want to convert, you can convert, but Newton over millimeter square is megapascal. Yeah, Newton over millimeter square, it's also 10 to the 6 Pascal. Yeah, so usually we go with that one. In SI units. Okay, now going back to the Pascal's triangle, or sorry, Pascal's law. The Pascal law states that any pressure or any force is transmitted from one end to another end. While doing so, the pressure is generated to all the sides as well. Any force that's applied to a confined fluid is transmitted in all directions. So this force is transmitted in all directions throughout the fluid. So from here all the way here, this is regardless of the shape of the container. I can change the shape of the container, but force or pressure will be distributed from this point to another point. Yeah. If there is any resistance at the output, for example, let's imagine this is an output and this is an input. If there is any resistance here, what will actually happen is the pressure will try to push it up. Yeah. If you push this one down, the pressure will push it up. The reason is because this fluid you are not able to compress. Sometimes we are able to compress a fluid little bit. The reason is because that fluid contain a tiny amount of air bubble, porosity, or something else in it. So we can compress that fluid. Liquids, solids are incompressibles. Okay, let's say we got a question. It's imagine it's a mechanical pneumatic ram where you are going to apply a force of 200 Newton. The diameter of this pipe is 20 millimeter. And on the other side, the diameter of the pipe is 60 millimeter. I want to find out what is the force on the other end. To do that one, we use a Pascal. Law. The Pascal law is pressure equals to force over area. We have the formula. So pressure equals force over area. So first I want to find out what is the pressure here. I cannot find the pressure at the point A. The reason is I do not know the value for the area. I have the diameter. So now to convert the diameter into radius, I will half it. So here the radius is going to be 10 millimeter. Now I need to find the area of this side. So we will use a formula pi r square. Now remember, this radius is actually in millimeter. So if you want to convert straight away into meters, you can. But when we get the pressure, I can straight away convert into megapascal straight away. So we can do that way as well. So find the area. That's the formula for the area. Here you have the value of the pi as a pi, and r is 10. 10 square, so that's 100 pi millimeter square. Will give you a value of 314.15 millimeter square. Area, I can find the pressure at A. So I'm just going to call the pressure at A as PA. Pressure at A is force, which is given as 200 Newton divided by 314.15 millimeter square. So if I divide that one, I will get an answer in a unit of Newton per millimeter square. If I want, I can convert that into megapascals. I can do that one because Newton per millimeter square is actually a megapascal. So now we got pressure at A is 0.6366 Newton per millimeter square, which I can write as 0.64. Let's round it off. 64 megapascal. Yeah, if I want to round it off, I can do that. Now, once I got the pressure at A, I need to find the force at the B. Now, to find the force at the B, what we need to do is we need to understand the concept that pressure at A, according to the law, the pressure at A should be same as the pressure at B. So that will have the same pressure. But before I look into the pressure at B, I need to find the area of the B. So let's find the area of the B. So to do that one, let's find the area of the B. Area is going to be pi r square. I do not have the value for the r. So r is going to be half of that one. So it's 60. So r is 30. 30 millimeter. I will use this formula to find the value of the area. So area is pi 30 square, which is 900 pi or 2827. So this is in millimeter square. Now I'm just going to use the Pascal law again for this side. I know the pressure, which is this law, force over area. So I will write down pressure at B is equal to force at B over the area at point B. Now I know pressure at B is same as pressure at A. So I can write this one down, pressure at A. Or I can use this value for the pressure, which is much more sensible because I don't have to convert back. So that is same as pressure at A. So pressure at A is 0.6366 and force at B I don't know, but the area at B I know. So if I make the FB the subject, force at B the subject, that will be